I have been thinking about a glass of water. Just a plain, ordinary glass of water sitting on a table. Nothing special. Nothing dramatic. It looks peaceful, but it shouldn't be there. According to the laws that govern its neighbors in the periodic table, that water should boil at -80 degrees Celsius. Not freeze. Boil. Turn to gas and disappear. Hydrogen sulfide? Gas. Hydrogen selenide? Gas. Hydrogen telluride? Gas. Every single compound in water's family is a gas at room temperature. The pattern is clear. The trend is unmistakable, and water breaks it completely. Something is holding those molecules together. Something that shouldn't be there according to the simple rules of the periodic table. An electrical quirk. A tiny asymmetry in the way electrons arrange themselves around oxygen. And that quirk, that one small deviation from what the periodic table predicts, is the only reason you're alive right now. The only reason any living thing has ever existed on this planet. Life as we know it is a complete physical impossibility. Except it isn't. Because of something Feynman found deeply disturbing about the nature of water. And when you understand what that something is, when you really see how close we came to never existing at all, you'll never look at a glass of water the same way again. Let me show you. Let us look at the evidence. We need to act like detectives. We look at the periodic table. We look at the column where oxygen lives. Group 16, and we ask a simple question. Who are the neighbors? Below oxygen, you have sulfur. Hydrogen sulfide. That is the rotten egg gas. You know the smell. The one that makes you wrinkle your nose and leave the room. It boils at -60 degrees Celsius. That is -76 degrees Fahrenheit. A gas long before you would ever feel comfortable standing in the room. Go down one step. Selenium. Hydrogen selenide. A nasty, poisonous gas. It boils at -41 degrees Celsius. That is -42 Fahrenheit. Still a gas at room temperature. Still nowhere close to being a liquid. Go down another step. Tellurium. Hydrogen telluride. Another gas. It boils at -2 degrees Celsius. About 28 degrees Fahrenheit. Just barely a gas at the freezing point of water. Do you see the pattern? As you go down the column, as the molecules get heavier from sulfur to selenium to tellurium, the boiling point goes up. Heavier things are harder to get moving. They need more energy to break free. They are harder to turn into gas. That makes sense. That is how the periodic table is supposed to work. So now we go the other way. Up the column, to the lightest one of all. Oxygen. The smallest atom in the family. Water. If the pattern holds, if the universe plays by its own rules, the boiling point should be the lowest of all. The line on the graph points directly at -80 degrees Celsius. That is -112 degrees Fahrenheit. But water boils at +100 degrees Celsius, 212 degrees Fahrenheit. That is a difference of 180 degrees from the prediction. Not a small error, not a rounding problem, not a measurement issue. A massive, embarrassing violation of the trend. Every other compound in this family obeys the rule, every single one. Sulfur, selenium, tellurium, they all fall in line. And water, the lightest of all, the one that should have the lowest boiling point, breaks the pattern completely. Nature is shouting at us. It is telling us that something different is happening here. Something that the periodic table did not predict. Something that the simple rules of molecular weight cannot explain. The question is, what? What is holding those water molecules together so tightly that you need 180 extra degrees just to tear them apart? To answer that, we have to go back. We have to think about what heat actually is. In the old days, people thought heat was a fluid. They called it caloric, like an invisible liquid that flowed from hot objects into cold ones. You heat a pot of water, you are pouring this fluid into it. Sounds reasonable, but it turned out to be completely wrong. Then came the idea that changed everything, one of the most powerful ideas in the history of human thought. And it is so simple you can say it in one sentence. All things are made of atoms, and they are always moving. That is it. If you learn nothing else about physics, learn this. Everything you see, everything you touch, everything you are, is made of atoms, and those atoms never stop moving. Not for 1 second. Not even at the coldest temperatures we can reach. Put your hand on the table right now. Feel the temperature, that solid surface beneath your fingers. What you are feeling is the jiggling of atoms, billions of them, vibrating back and forth. When we say something is hot, what we really mean is that the atoms are jiggling faster. When we say cold, they are jiggling slower. That is all temperature is, speed of jiggling. So what happens when you boil a liquid? You are adding heat. You are making the molecules jiggle harder and harder. They are banging against each other, pushing and shoving, colliding with increasing violence. And if you give them enough energy, if you make them jiggle violently enough, they break free from their neighbors and fly off into the air. That is evaporation. That is boiling. The molecules escape the crowd. They go from liquid to gas. Now here is the question that should bother you. Hydrogen sulfide is heavier than water. It should be harder to lift, harder to get moving, but it flies apart easily at -60 degrees. Water is light, the lightest in the family. It should fly apart with a tiny nudge, but it does not. It sticks. It sticks together with a tenacity that is frankly shocking. Why is it so hard to make water fly? The answer has nothing to do with weight, and everything to do with something invisible, something electrical, something electrical. Let us look inside the water molecule itself, because the answer to our mystery is hiding in there. Most people think water molecules stick together because of gravity, or because of weight, or some vague idea about molecular attraction. All wrong. The real answer is so strange, so counterintuitive, that when you see it, you will wonder why nobody told you sooner. Let us start with oxygen. Oxygen is a bully. I do not mean that as a metaphor. I mean it as a precise description of how oxygen behaves at the atomic level. In chemistry, there is a number that measures how greedy an atom is for electrons. It is called electronegativity, and oxygen scores a 3.44 out of 4. That is one of the highest scores of any element in the entire periodic table. Only fluorine is greedier. That is it. Out of 118 elements, oxygen is the second most aggressive electron thief in existence. Now, hydrogen scores a 2.2. That is low. Hydrogen is small. Hydrogen is weak. Hydrogen has 1 electron and barely holds on to it. So what happens when you put them together? Oxygen grabs the shared electrons and pulls them closer to itself. Not all the way. This is not robbery. It is more like a tug of war where one side is much, much stronger. The electrons spend more time near oxygen, less time near hydrogen. And this is where it gets beautiful. Picture the water molecule. You have seen diagrams of it before. But forget those flat, boring textbook drawings. Think of it in 3 dimensions. It looks like Mickey Mouse. I am serious. The oxygen atom is the big round head, and the two hydrogen atoms are the ears, sticking out at an angle of 104.5 degrees. Not 180. Not a straight line. A bent, asymmetric, lopsided shape. And because oxygen is hoarding the electrons, the head of Mickey Mouse, the oxygen end, carries a slight negative charge, and the ears, the hydrogen ends, carry a slight positive charge. You now have a molecule with a positive side and a negative side, a molecule that is electrically lopsided. In physics, we call this a dipole, a tiny electrical magnet. And here is where everything clicks. When you put billions of these tiny magnets next to each other, the positive ears of one molecule reach out toward the negative head of another. They lock on. They grip. They hold. That grip has a name. It is called a hydrogen bond. It is not a full chemical bond. It is about 1/20th the strength of the bond holding oxygen and hydrogen together inside the molecule. But it is there, and it is everywhere. Every single water molecule in your glass is connected to its neighbors by these invisible electrical threads. Up to 4 hydrogen bonds per molecule, reaching out in every direction, forming a web, a network, an invisible electrical scaffolding that holds the entire liquid together. And that is why water is liquid at room temperature. Not because it is heavy, not because of gravity, because every molecule is electrically glued to the molecules around it. The periodic table did not predict this. The simple rules of molecular weight could not account for it, because this is not about weight, this is about shape and charge, and a bully named oxygen. But you might be wondering, if electrical attraction is so powerful, why do other molecules not do the same thing? Great question, and the answer will surprise you. Let us go back to hydrogen sulfide, the rotten egg gas, water's closest cousin. Sulfur is bigger than oxygen, much bigger. An atom of sulfur weighs twice as much as an atom of oxygen. If you were betting on which molecule would be harder to pull apart, you would bet on hydrogen sulfide every time. But you would lose that bet. Here is why. Sulfur has an electronegativity of 2.58. Hydrogen is 2.20. The difference? Just 0.38. That tiny gap means sulfur barely pulls the electrons toward itself. There is almost no charge separation, almost no positive end, almost no negative end. The molecule is nearly neutral, and a neutral molecule cannot grab its neighbor. It has nothing to hold on with. No electrical grip, no hydrogen bonds, nothing. Imagine a crowd of people at a concert. The hydrogen sulfide molecules are like people covered in grease, head to toe. They bump into each other. They slide past. They cannot hold on. One small push, a little bit of heat, and they scatter. They fly apart. Gas. Now imagine the water molecules. They are covered in Velcro. Every surface has hooks. Every molecule reaches out and grabs onto its neighbors. You push one and it drags the others with it. You try to pull one away, and 3 more hold it back. That is the difference. That is the entire explanation for why water is liquid and hydrogen sulfide is gas. Greased people versus Velcro crowd. And the numbers back this up precisely. The energy required to break one hydrogen bond in water is about 23 kilojoules per mole. That does not sound like much. But remember, every single molecule has up to 4 of these bonds, and there are 33 billion trillion molecules in a single teaspoon of water. That is 33 followed by 21 zeros. The total energy holding a single teaspoon of water together is enormous. Far more than the simple weight of those molecules would suggest. Far more than the periodic table predicted. So when you boil water, you are not just making molecules jiggle faster. You are ripping apart an electrical network. And you are tearing through billions of tiny invisible bonds, one by one, until the molecules finally break free. And that takes energy. A lot of energy. 180 degrees more than the periodic table said it should. Now you know why. But here is what Feynman found truly remarkable. It was not just that water sticks together. It was what happens because it sticks together. The consequences, the implications for everything alive. And those consequences, they are far stranger than you think. So water sticks together. It boils too high. Rule number 1, broken. But that is not the only rule water breaks. Let us talk about what happens when water gets cold. In almost every substance in the universe, when you cool it down, the atoms slow down. They pack tighter. They get closer together. The solid form is denser than the liquid form. Always. This is one of the most reliable patterns in all of physics. Iron? Solid iron sinks in molten iron. Of course it does. The solid is denser. It falls. Copper? Same thing. Solid sinks. Aluminum? Sinks. Gold? Sinks. Every metal, every mineral, nearly every substance you can name. When it freezes, it gets denser. When it gets denser, it sinks. Now take an ice cube, drop it in a glass of water, it floats. You have seen this 1,000 times. You have never questioned it, but you should. Because it is one of the strangest things in nature. Solid water is less dense than liquid water. That violates the rule. That breaks the pattern that nearly every other substance in the universe follows. Why? Remember that angle. 104.5 degrees. The Mickey Mouse shape. When water freezes, those hydrogen bonds do not just hold on. They organize. They lock into position. They form a hexagonal lattice, a crystal structure with 6-sided symmetry. Like a honeycomb. And here is the key. That hexagonal structure has holes in it. Empty space. Gaps where molecules could fit, but do not. The crystal is less tightly packed than the chaotic liquid. Ice expands. It takes up about 9% more volume than liquid water. That is why ice floats. That is why your pipes burst in winter. That is why icebergs sit on top of the ocean instead of sinking to the bottom. And now, here is where it becomes a matter of life and death. Imagine if ice behaved normally. Imagine if it sank. A lake in winter. The surface freezes, but instead of floating, the ice sinks to the bottom. More water is exposed to the cold air. That freezes too. It sinks. More freezes, more sinks. Within weeks, the entire lake is frozen solid, from bottom to top. Every fish, every organism, every microbe, dead. And in spring, the sun hits the surface. But ice is a terrible conductor of heat. The sunlight cannot reach the bottom. The deep ice never melts. Next winter, it freezes even deeper. And the winter after that, deeper still. Within a few centuries, the oceans would be frozen solid, a permanent ice age. No liquid water anywhere on the surface of the earth. No life. Not a single cell. Not a single organism. Nothing. The entire possibility of biology on this planet hangs on the fact that the water molecule is bent at an angle of 104.5 degrees. That angle creates the hydrogen bonds. Those bonds create the hexagonal lattice. The lattice creates the empty space. The empty space makes ice float. and floating ice insulates the water below, keeping it liquid through the winter. Keeping life alive. One angle, one shape, one quirk of electron arrangement. And without it, no life on Earth. Ever. So water breaks two rules. It boils too high and freezes too light. Both violations. Both caused by the same thing, hydrogen bonds. Both essential for your existence. But those hydrogen bonds do something else. Something you feel every second of every day without ever knowing it. Let us go back to sulfur for a moment. Same column on the periodic table, same family, same basic rules, but different tweaks. Sulfur is bigger. Weaker pull on electrons. Gap of 0.38 instead of 1.24, nearly neutral molecule. So what does hydrogen sulfide do? It exists as a gas. It smells terrible. It dissolves almost nothing. It has no structure, no network, no grip. Water, same basic recipe, different tweaks, holds the entire planet together. Same rules, different consequences. That is what Feynman found so disturbing. The difference between a dead gas and the molecule of life comes down to one number. The electronegativity gap, the angle, the shape, and the consequences go deeper than you think. Let me ask you something. Have you ever actually touched anything? I mean really touched it. Skin against surface, finger on glass, hand on table. You have not. No one has. No human being in the history of the species has ever truly touched anything. Not once. Here is why. The atoms in your fingertip are surrounded by electron clouds. And those electron clouds are negatively charged. The atoms in the table are also surrounded by electron clouds. Also negatively charged. Negative repels negative. When your finger approaches the table, the electron clouds push against each other. They compress. They resist. They create a force that feels exactly like touching. But there is always a gap. About 1 angstrom. 1/10,000,000th of a meter. You are hovering. Right now. Your body is not resting on the chair. It is floating 1 angstrom above it, suspended by electrical repulsion. That is rule break number 3. You are an electrical being. Your entire physical experience, every sensation of touch, every feeling of pressure, every object you have ever held, is an electrical illusion. Electron clouds pushing against electron clouds, and water. Because of those same hydrogen bonds, because of that same electrical asymmetry, takes this even further. Watch a pond in summer. Look at the surface. You will see insects walking on it. Water striders, pond skaters, tiny creatures standing on top of the water as if it were solid ground. They are walking on an electric trampoline. The surface of liquid water is held together by hydrogen bonds pulling inward. Every molecule at the surface is being dragged toward the center by its neighbors below. This creates a skin, a membrane, in surface tension, strong enough to hold an insect, strong enough to make water creep up the inside of a thin tube against gravity, strong enough to pull water from roots to treetops in the tallest trees on Earth, over 100 meters or 330 feet straight up. And there is one more thing, perhaps the most important of all. Water dissolves more substances than any other liquid on Earth. Chemists call it the universal solvent. Acids, bases, salts, sugars, charter gases. Water pulls them apart and wraps around them. And it does this because of the same electrical asymmetry. The positive hydrogen ends attract negative ions. The negative oxygen end attracts positive ions. Water molecules surround each dissolved particle like a wet glove, pulling it away from its neighbors, dispersing it into solution. This is not just chemistry. This is biology. Every protein in your body is folded into its precise shape by water. Water molecules press against the protein surface, pushing hydrophobic regions inward, stabilizing the structure. Without water, proteins unfold. Enzymes stop working. DNA cannot replicate. Metabolism halts. NASA does not search for oxygen on other planets. They do not search for carbon. They search for water. Follow the water. That is the actual directive. Because where there is liquid water, the chemistry of life becomes possible. Where there is no liquid water, it does not. You do not just contain water. You are water doing something remarkable. Think about it. The boiling point, the ice floating, the bug walking on the surface, your blood flowing through your veins, your proteins folding into shape, your DNA copying itself. It all comes back to that one thing, a bent molecule, an angle of 104.5 degrees, an oxygen atom that pulls a little too hard on its electrons, a tiny electrical asymmetry that creates hydrogen bonds. One quirk, and everything alive depends on it. But what would happen if you took it away? What would happen if, for just 1 second, every hydrogen bond on Earth stopped? Imagine that. Let us do exactly that. Let us imagine it. 1 second. That is all I am asking you to picture. 1 single second where every hydrogen bond on Earth simply stops. The electrical grip between water molecules, gone. Not weakened, not reduced. Gone. What happens? Start with your body. You are 60% water. Every cell in your body is held together by membranes. Thin barriers made of molecules arranged by hydrogen bonds. In the first millisecond, every cell membrane in your body dissolves. Not ruptures, dissolves. The walls between your cells simply cease to exist. Your proteins, every enzyme, every antibody, every hemoglobin molecule carrying oxygen in your blood, they are folded into precise shapes by water. Water molecules pressing against them like a wet glove, holding them in exactly the right configuration to function. Without hydrogen bonds, that glove disappears. Every protein in your body unfolds, instantly, like a zipper with no teeth. They become formless chains of amino acids, useless, dead chemistry. Your DNA, the molecule that carries the instructions for every living thing on Earth, is a double helix. 2 strands twisted together. And what holds those 2 strands together? Hydrogen bonds, thousands of them, running like rungs on a ladder from one strand to the other. In 1 second, every strand of DNA in every cell in every living thing on Earth unravels. But that is just biology. Let us go bigger. The oceans, 1.335 billion cubic kilometers of water. Right now, every one of those molecules is gripping its neighbors, holding on, forming that Velcro crowd we talked about. Without hydrogen bonds, there is nothing holding those molecules together. They do not need heat to fly apart. They do not need energy. The bonds that kept them liquid are simply no longer there. The oceans do not boil. They flash into vapor, instantly. Every river, every lake, every drop of rain still falling through the sky, gas in 1 second. The atmosphere would balloon with water vapor. The pressure would spike. And then, because there is nothing to pull those molecules back together, the water would never return. It would remain a gas forever. In 1 second, every living thing on Earth ceases to exist. Not from violence, not from heat, not from an explosion, from the simple absence of one electrical quirk in how oxygen shares electrons with hydrogen. That is how thin the line is between a universe teeming with life, oceans, forests, whales, bacteria, you, and a universe of dry, dead gas. The only difference is a tiny electrical asymmetry in a molecule shaped like Mickey Mouse. One quirk, one angle, one bully of an atom. And here is what should really disturb you. The universe does not require hydrogen bonds. There is no law of physics that demands them. They are not fundamental forces like gravity or electromagnetism. They are consequences, side effects, happy accidents of how electrons arrange themselves around oxygen. The universe would be perfectly legal without them, perfectly consistent, perfectly described by the same equations, just empty of everything we call alive. This is not just a thought experiment. Scientists take this very seriously. So seriously, in fact, that they have built their entire search for life in the universe around this one molecule. When NASA sends a rover to Mars, there is a directive, an actual, official strategy that guides every mission, every instrument, every landing site. 3 words: follow the water. Not follow the oxygen, not follow the carbon, not follow the organic molecules. Water. Because NASA scientists understand what you now understand, that liquid water is not just one ingredient in the recipe for life. It is the recipe. Without it, proteins cannot fold, membranes cannot form, chemistry cannot become biology. Think about that. The entire space program, billions of dollars, tens of thousands of scientists, decades of engineering, all of it chasing one molecule, the same molecule sitting in the glass on your table right now. In 2015, when NASA confirmed evidence of liquid water flowing on the surface of Mars, seasonal dark streaks on crater walls called recurring slope lineae, it was front-page news worldwide. Not because water is exotic, but because water means possibility. Water means hydrogen bonds. And hydrogen bonds mean the machinery of life can exist. When the James Webb Space Telescope analyzes the atmospheres of exoplanets orbiting distant stars, what is the first molecule it looks for? Water vapor. Because if you find water in the atmosphere of a rocky planet in the habitable zone, a planet at just the right distance from its star for liquid water to exist, you have found the most promising candidate for life outside our solar system. Every discovery in astrobiology comes back to this. Every mission, every telescope, every dollar spent searching for life beyond Earth. They are all looking for hydrogen bonds. They are all looking for that one electrical quirk, that one angle, that one bully atom. And the remarkable thing, the thing that should give you chills, is that you are made of it. You are swimming in it. You drink it every day without a second thought. The rarest, most precious molecule in the known universe, the one that entire civilizations of scientists are desperately searching for on other worlds, is running out of your kitchen faucet right now. And it has more tricks, more rules it breaks, more impossibilities it commits every second of every day. Here is one more trick, one more rule that water breaks. If you heat a kilogram of iron by 1 degree Celsius, it takes about 450 joules of energy. If you heat a kilogram of water by the same 1 degree, it takes 4,180 joules, nearly 10 times more. Water absorbs more heat per degree than almost any common substance on Earth. Chemists call this specific heat capacity, and water's number is absurdly high. Why? Hydrogen bonds. Again. When you add heat to water, you are not just making the molecules jiggle faster. You are also stretching and breaking hydrogen bonds. And those bonds absorb energy. A lot of energy. Before the temperature can rise, you have to fight through that electrical network first. The Velcro crowd does not just resist separation, it resists heating. And this changes everything about how Earth works. The oceans absorb enormous amounts of heat from the sun during the day, and they release it slowly at night. This is why coastal cities have mild climates. San Francisco, surrounded by water, rarely drops below 5 degrees Celsius or rises above 25. That is 41 to 77 degrees Fahrenheit. A narrow, gentle range. Go inland. Phoenix, Arizona. Same latitude. No ocean buffer. Summer temperatures hit 46 degrees Celsius. That is 115 degrees Fahrenheit. Winter nights plunge near freezing. Same sun, same distance. Completely different worlds. Because one city has an ocean of hydrogen bonds absorbing the shocks, and your body does the same thing. You are 60% water. That water acts as a thermal buffer. When you exercise and your muscles generate heat, your body temperature does not spike instantly because all that water absorbs the excess. Your internal thermostat, your ability to survive a hot day or a hard run, depends on the same electrical quirk that makes a glass of water sit peacefully on your table. Same molecule. Same bonds. Same Mickey Mouse shape. So let us count. Rule 1. Boiling point 180 degrees higher than predicted. Rule 2. Ice floats when it should sink. Rule 3. You have never touched anything. Rule 4. Dissolves more substances than any other liquid. Rule 5. Absorbs more heat than almost anything on Earth. 5 rules broken. 5 impossibilities. All caused by the same thing. And that brings us to the part that disturbed Feynman most. Here is what bothered him. None of this was guaranteed. There is no law of physics that says oxygen must be electronegative. No law that says hydrogen must be small and weak. No law that says the angle must be 104.5 degrees instead of 180. If that angle were different, if the molecule were straight instead of bent, there would be no dipole, no hydrogen bonds, no liquid water, no ice floating, no heat capacity, no surface tension, no universal solvent, no life. The entire thing hangs on geometry, on an angle. On the way, electrons happen to arrange themselves around one particular atom. Feynman understood this. He understood that the laws of physics are elegant and beautiful and consistent, but they do not care about us. They do not require life. They do not demand oceans or forests or whales. The universe works perfectly without any of it. And yet, here we are, made of water, breathing because of hydrogen bonds, thinking because of an electrical quirk in a molecule shaped like Mickey Mouse. That is not comforting. That is not reassuring. That is not the kind of answer that makes you feel safe. But it is honest. And Feynman always preferred honest answers to comfortable ones. So let us come back to where we started. A glass of water, sitting on a table. Ordinary, unremarkable. Except now you know what it really is. A molecule shaped like Mickey Mouse, bent at 104.5 degrees. An oxygen atom that pulls too hard on its electrons. A tiny electrical asymmetry that creates hydrogen bonds. And those bonds, those invisible electrical threads, break 5 rules of physics. They make water boil 180 degrees higher than the periodic table predicts. They make ice float when every other solid sinks. They create an electrical illusion so complete that you have never truly touched anything in your life. They dissolve more substances than any other liquid on Earth, and they absorb more heat than almost anything, turning the oceans into a planetary thermostat. 5 impossibilities, all from one quirk, one angle, one bully of an atom, and none of it was guaranteed. The universe does not require hydrogen bonds. It does not need liquid water. It does not demand oceans or forests or whales or you. It would work perfectly without any of it. That is what Feynman found disturbing. Not that water is remarkable, but that it did not have to be. That the entire possibility of life hangs on a geometric accident, a molecule that bends instead of staying straight. That is not comforting, but it is honest, and you will never look at a glass of water the same way again. If this changed how you see water, even a little bit, tell me in the comments. What surprised you most? The Mickey Mouse shape? The ice anomaly? The fact that you have never touched anything? Subscribe if you want more physics explained the way Feynman would have explained it. No memorization, just understanding, and I will see you in the next one.